All right. Hi, guys. We are finishing something in chapter 6.2 that I forgot to put in that first video that I made for you. This is work problems. So these were originally on your homework, and then I took them off for sake of confusion, but we're going to learn them today so we can be responsible for them. So we're talking about work. These are kind of physics problems. So if we have F, which is force, and that's a constant force in any direction. If we have F, then the work done by F in moving an object from point A to point B is W equals F times magnitude of AB times cosine theta. Okay, let's talk about what these things mean. So first thing, F is force. It also can be the weight. So sometimes it's saying you're going to pick up something that weighs this amount. That's the force because it's the force that's being put onto the earth in order to pick it up or move it. That's what weight is a force onto the earth. Then the next thing is this vector AB. It represents the distance, but it also represents the direction, but since we're doing the magnitude, we're doing the distance of that direction. So we're finding the magnitude of the vector that's given to us, which means that we're looking at the distance of it. And then we're doing cosine of theta, and theta is the angle formed by the vector. So from your vector. In this case, the example that we have, we're going to do just one example so you have one to look at when you look at other ones. It says find work done by a 10-pound force acting in direction 1, 2 in moving an object 3 feet from 0, 0 to 3, 1. So 3 is the distance that we're moving it. The next thing we got to do is recognize force. Well, force is the weight, or it physically says force there, so I'm going to label that as my force. And then the only other thing I need to do is find my theta, my angle. So we're given this vector, and so that's going to help us find my theta. So you can do one of two things. The way that we've been doing it is knowing that like your vector, like 1, 2, is equal to the magnitude of that vector times cosine theta, and then magnitude of the vector times sine theta. So that gives you your x and y. So we could do like 1 equals the magnitude cosine theta. So that's one option. Another option we could do is the way vectors are done is they go from the origin to a point out. So it goes to the point 1, 2. So I go over 1 and then I go up 2. So I've got this little right triangle, and we can just do tangent of theta equals 2 over 1. Just some basic trig. Theta equals inverse tangent of 2, and so theta equals 63.4. Either way, if you do this and find the magnitude and then set that equal to 1, or do inverse tangent, you'll get theta equals 63.4. Okay, so now that I have these pieces and distance and force, I'm going to say work equals 10 times 3 times cosine of 63.4, and then we're just going to solve. So I'm going to I can throw that all in my calculator. 10 times 3 times cosine of 63.4. Now make sure if you were playing around with your mode earlier that you're still in degrees, because that is a degree, and I get work equals 13.43. And that's it. The end. The only other thing about this problem is that my unit on this is something kind of weird. It's called foot-pounds, so you can say FT and then LBs. That's just the unit on weight, and that's how you solve these. So look for, in your homework, there'll be a couple questions from 6.2 and a couple from 6.4, and then this is how you do the 6.2 ones. Again, if you need any help, let me know. Have a good day, guys. Bye.